Okay, so let's take a look at the third part of naming ionic compounds. So, in the first two videos on naming ionic compounds, we were looking at where the metals were on the periodic table. And if they only gave up the same number of electrons each time for a particular element, then we did not need a Roman numeral in the name to indicate the charge of the metal. So what I have here again on this periodic table is that my group 1 and 2 metals, along with the ones circled here, if they are part of a formula, you don't need a Roman numeral. In fact, you don't need it, you're not going to put it. If you're dealing with the transition elements here in the middle, you need to figure out what number or what Roman numeral goes in the name based on the charge of the metal, and the only way you can do that is to check out what the charge was for the non-metal. So you got work with the number of times that the metal and non-metal appear in the formula, and then the charges associated, because when you have a compound, remember it's electrically neutral. So your electrons lost have to balance out your electrons gained. But now this third and final step here is when you're dealing with naming compounds that contain polyatomic ions. So, polyatomic ions means you have clusters of atoms that act as an ion and together as a cluster have a charge. So if you take a look at these formulas that I've listed here, just a few examples, I have a metal and then I have a poly. I have a metal, I have a poly. I have a metal, I have a poly. Now I know I have a polyatomic ion in these compound formulas because you have more than two elements in the formula and the first element is a metal. When I name compounds that contain polyatomic ions, I'm just going to use the entire polyatomic ion name. So just like when I have a metal that only gives up one number of electrons and I use that name and I don't need the Roman numeral, the same thing happens with polyatomics. So, you must memorize polyatomic ions and their charges. Don't cut corners, don't skip steps here, because then it'll be very hard for you to see how to name compounds. Or the flip side, of course, is writing the formulas from the compounds. So what I listed here are just a few of some of the common ones. Take a look in your textbook or the notes or handouts that your teacher or professor gave you to what you need to know for the course. Sulfate is SO4 and it has a -2 charge, 2 minus. Sulfite is SO3, 2 minus. Nitrate is NO3 minus. Nitrite is NO2 minus. Hydroxide, OH minus. Ammonium. This is interesting because ammonium is actually a polyatomic ion with a positive charge. So we'll talk about that at the end of this video. And then phosphate is another example of a common one, which is PO4, 3 minus. Again, this is only some of them. You need to memorize them. If I go back here to the beginning, let's name them then. Well, Na, you should recognize, of course, that is sodium. And SO4, I recognize as the polyatomic ion sulfate. So that's it. This is sodium sulfate. I go to the next formula. I have Zn, that's zinc. Zinc, while it's not in group 1 or group 2, is over here. It only gives up the same number of electrons. I don't need the Roman numeral, just zinc. And I have a poly. I know that because I have a metal first and then more than one non-metal. And this is hydroxide. So this is zinc hydroxide. And finally, for the last one, Pb is lead. I know I have a poly again because I have a metal written first and then more than one non-metal. I go to the periodic table. Oh, wait a minute. Lead happens to be here. It is a metal, and it's not one of the ones that gives up the same number of electrons each time, so I need the Roman numeral. So I know I'm going to have lead with a Roman numeral. I just don't know what it is yet. Well, let's figure it out based on the phosphate. So PO4 is phosphate. I would put in the entire name. Maybe I can't write it too great here on the screen, but it's phosphate. And phosphate, you have to memorize, again, not just the formula, but the charge is 3 minus. So, in other words, that cluster wants to grab 3 electrons per cluster. So now I'm back to figuring out what the charge is here for lead. Well, each phosphate polyatomic wants 3 electrons. I have 2 of them. That's a total of a -6. If phosphate needs 6 electrons, it's getting 6 electrons from the leads, but I have 3 of them. Right? So 6 divided by 3 is 2. So this must be lead to phosphate. So figuring out whether or not I have a transition metal or not is no different than looking at the video that was before this one. The new addition here, of course, are the polyatomic ions. Now, one other thing I did want to mention, I told you at the end, and I apologize, this is an NH3, this is NH4. The ammonium polyatomic ion is NH4+. What if we had something like NH4Cl? Now the polyatomic ion is written first because it is the positive ion, and all I'm going to do is use the name. So this is just ammonium. And Cl, again, it's not ammonium chlorine, it's just ammonium chloride. Alright, sorry for the mess up with the ammonium ion. Keep working hard. Go over the videos. Come back to these when you need them. You'll be using naming of inorganic compounds, and check out videos on writing formulas. And keep working hard. Good luck.